Okay, for the next part of this lesson, again 8-2, we're going to continue on with finding trigonometric ratios with an angle. So this one's mainly using the calculator, so let's put the calculator on the screen here. Let's see, make sure that shows up properly. Alright, it's a little bit far. We're beginning on page 7 of the PDF for topic 8-2. So again, if you don't remember how to use the scientific calculator to find sine, cosine, and tangent of an angle measure, remember there are a few things first. Let's look up here next to where the 0 is on the screen. If you look at the 0, you want to look for this symbol, or not symbol, but you want to look for the letters D, E, G. That means the calculator is set in degrees. Because if the calculator is not set in degrees, then your answers are going to be incorrect. So you've got to make sure that it's set to degrees. Now, if you do not see this DEG, what do? Well, look for this key, DRG. This changes the setting. So if you're already in degrees, let's just push the button so you can see what happens. Press it once. You'll see it changes to RAD. That stands for radians. Again, that's another unit of measure for degrees. Kind of like we have, feet, inches, meters, so on and so forth to measure distance. Angles can be measured in degrees, radians, and if we press the button again, gradients. Again, not the system we want to be in. Okay, so press it one more time, takes us back to degrees. Now we're in business. That's where we want to be. Right, so with these simpler scientific calculators, you simply type in the angle measure and then hit the appropriate button. So a few examples from the assignment. Let's do one for each. So you have, again, this is on page 7. Let's go over here. So you should see cosine of 76. So again, simply type in 76. We want cosine. And there you go. You should get this number that takes up the entire screen. Directions say round to the nearest hundredth. So we simply round to 2 decimal places. The 4 is followed by a 1, so it stays as 0.24. So approximately, that's what this symbol means. Instead of an equal sign, you have 2 wavy lines. It's a symbol for approximation. So cosine of 76 is approximately 0.24. If we go to the next example, directly below it, tangent of 11. And well, if we're looking for the tangent of 11, type in 11, hit tangent, and we get this number. Again, nearest hundredth, 2 decimal places, 0.19. The 9 is followed by a 4. So we stay put at 0.19. And finally, one for sine. Now we have here in the middle column sine of 62, so let's do that one. Sine of 62. Type in 62, hit sine. Nearest hundredth, 2 decimal places. The 8 is followed by a 2. So 0.88. Let's look for one where we have to round. There you go, perfect. Cosine of 30. Third column, middle question. You have the cosine of 30. So if we type that in, 30 cosine, we get 0.866. And since the second 6, the 100th place, is followed by a number equal to or greater than 5, that's why this one rounds up to 0.87. Remember, that is the rule that we follow here. Very important that you remember that, because if you do not round appropriately, the answers will be counted incorrectly. Count as incorrect. Okay, so What does this part help us with? Well, this part is actually, the point here is so you know how to use the calculator so that we can solve for missing side lengths of a right triangle. So if we go on to page 8, there are a couple of examples on how you can use trigonometric ratios, trigonometric functions, to find the missing side of a right triangle. Generally, we rely on Pythagorean theorem, because if we have a right triangle, we can use a squared plus b squared equals c squared to find the missing side length. Now that's not always an option, as evidenced by these examples. Let's look at the first triangle. Again, we're in slide 8 now. And we're going to be working on the triangle on the left-hand side of the slide. ABC, where the right angle is at B. Angle A is given to us as 41 degrees. And CB, 6.1 inches. Now this question is asking us to solve for the lengths of AB and AC. So we'll do the two examples, using this triangle here. Okay, so how do we use trigonometry? Again, we can't use the Pythagorean theorem because we only have one side. If you're going to use Pythagorean theorem, a squared plus b squared equals c squared, you need two of the variables to solve for the third. Either a and c to solve for b and c to solve for a, or a and b to solve for c. We only have one of the legs. Okay, but we have one of the legs and an angle, so we can use our trigonometric functions. So again, they're functions, so that means they have an input variable and they have an output. They have an independent variable and a dependent variable. For sine, cosine, and tangent, your independent variable is the angle measure itself. Remember the previous video at the beginning of the lesson, you have your sine of the angle. That's to generalize, let's call it, or you have the sine of angle A equal to the length of the opposite leg, abbreviating opposite OPP, divided by the hypotenuse. Okay, so here's our independent variable, and the ratio is our dependent variable. So this ratio depends on the measure of the angle. Okay, so now, well, since we started off with sine, let's use that one first. Or rather, let's take a step back. We know we have our three functions, so let's outline our three functions. Sine, cosine, and tangent. Because in order to find the missing side, you have to determine which of these is the appropriate one to use. So let's first work with what we have, what we know. All right, well, if angle A is over here, the 41 degrees, well, how does CB, how does the 6.1 relate to angle A? Is it opposite, adjacent, or hypotenuse? Well, like I said, hypotenuse is the easiest one to identify. Here's the right angle, so the hypotenuse is going to be AC. Let's label that one hypotenuse. Now, with respect to the given angle, the 41, 6.1 is our opposite. It's on the opposite side. It is across from the 41. So here is our opposite, and therefore AB is the adjacent. So if we're working off what we know, since we know the value of the opposite side, well, then we can eliminate cosine as a possible method of solving the problem. Because here we end up with two unknowns. I don't know the length of the adjacent leg. I don't know the hypotenuse. all I do know, the measure of the angle. So too many unknowns. So it's got to be sine or cos or sine or tangent. Well, that depends on what we're solving for. Now, if we are solving for the hypotenuse AC, well, then that leaves us with sine as the way to go. We have the angle 41, we have the opposite leg 6.1, and we have our variable hypotenuse AC. So now we use substitution. Let's bring it over here. Okay, so then the sine of 41, like it's substituting A with the angle measure, is equal to 6.1, the length of the opposite leg, divided by the hypotenuse AC. There's a little trick that you can use here to help you solve this quickly. Since the variable's in the denominator, well, we can't solve for a variable in the denominator, we need to bring it up to the numerator. So to quicken the process, we can simply trade off the sine and the AC, and the length of the leg. So rewriting our function, AC is equal to 6.1 divided by the sine of 41. Okay, the variable is isolated. Now we know what we need to solve for. Now, this part is important. We're gonna have to use our calculator now. Okay, we can't figure out sine of 41 without the calculator, so we have to use the calculator. Now this can be typed in all at once, but you have to be very careful how you do it. Remember, this is saying 6.1 divided by the sine of 41. So if you follow this process exactly, this is how you get the solution. Start off by typing the numerator, 6.1. We are dividing, so dividing by the sine of 41, so 41 sine. Then we hit the equals key. So that's our final answer. AC is equal to 9.297943829. Now you don't have to write the whole thing. I'm just doing this for the purposes of the demonstration. Directions say round to the nearest hundredth. Well, then that's 2 decimal places. The 9 is followed by a 7. So AC is approximately 9.3, or 30 if you choose. Again, the 7 rounds the 9 up to a 10, which in turn rounds the 2 to a 3. So the length of AC is 9.3 inches. Okay, so that's actually, so now what about the adjacent side over here? Well, we know 6.1 is the opposite, AB is the adjacent, so we turn to tangent. Because we know the angle, we know the opposite, the only thing we don't know is the adjacent. So tangent 41 is equal to 6.1 divided by the adjacent leg is AB. In this case, let's use a variable. You're welcome to use variables, so we'll call it y. And we can use the same tactic we used previously. Since the variable is in the denominator, we can simply trade the trigonometric function with the variable, save ourselves a little bit of trouble. So y is equal to 6.1 divided by tangent of 41. Then we just do the same thing we did before. 6.1 divided by tangent of 41 equals, so we get 7.017247284, nearest hundredth, 2 decimal places only. The 1 is followed by a 7, so y which is the variable we use to designate AB, is 7.02 inches. So let's do the second example as well, so you can see the alternative, because this is one way that these problems will be worked out. The variable will be in the denominator. In other cases, the variable will be in the numerator. So let's look at how that differs from this process here. We'll only do one of them. Okay, so on that same slide, 8, you are also given triangle NMP where angle N is 20 degrees and NP is 8.7 centimeters. In this case, NP, well, again, let's identify with this what we know and what we don't know. So our right angle is at vertex M, therefore NP is our hypotenuse. Angle N, the 20 degrees, is over here on the left. MP is therefore the opposite, it is across from where we are. So opposite, and NM are adjacent. So let's begin by solving for NP and look at what we know. Sine of N opposite over hypotenuse, cosine of N adjacent over hypotenuse, tangent of N opposite over adjacent. We know the hypotenuse, the value of the hypotenuse, so then tangent is no good. And we don't know the opposite, we don't know the adjacent, we only know the angle. Can't do anything with this. With sine and cosine, we know the angle, we know the hypotenuse, there is only one unknown. So let's start here. Or rather, let's start with MP. MP is the opposite of angle 20. So sine or cosine, sine. Setting it up, sine of 20 is equal to MP divided by hypotenuse NP, 8.7. Now, unlike the previous example, now the numerator is where the variable is. So all we have to do is get rid of 8.7. Well, it's just like any other algebraic problem. Got to isolate that variable. So how do we get rid of the 8.7? Well, it's MP divided by 8.7, so we have to use the inverse operation to cancel out, what we don't want. MP is divided by 8.7, so if we want to get rid of 8.7, we must multiply by 8.7 on both sides. 8.7 cancels out, so now 8.7 times the sine of 20, let's put the little star right here for multiplication, is equal to MP. Now generally the variable's on the left, so let's go ahead and switch that around. MP is equal to 8.7 sine of 20. So now turn to our calculator. 8.7 times, let's put that little star right there, times 20 sine equals, and we get 2.97557524 7. Again, just for the purpose of the demonstration, you don't have to write the whole answer down. Rounding to the nearest hundredth. 2 decimal places. 7 is followed by a 5. So our final answer, MP, is approximately 2.98 centimeters. So that's how you do the next part of the lesson here. When you have to find a missing side using, the trigonometric functions, an angle, and one of the sides.